Hey guys, so today we're going to talk about solving simple equations. All right, the first thing is look at the state standards. These are the things that we need to be able to do when we finish going over these standards. So we need to be able to create, use, understand, explain, construct, justify, solve, and represent simple equations. Okay, so our success criteria, this tells us if we're going to be successful or not. You need to be able to apply properties of equality to produce equivalent equations. You need to be able to solve linear equations using addition, subtraction, multiplication, and division. And you need to be able to write a linear equation that models a real life situation. All right, vocabulary that you need to know. Make sure that you have these in your notes and go over these and you understand them. Also, your properties of equality. These are very important. Addition property, if A equals B and you add C to both sides, they're still equal. Subtraction property, if A equals B and you subtract C from both sides, they're still equal. And substitution property, if A equals B, then A can be substituted for B or vice versa in any equation or expression. Multiplication and division properties. Okay, if A equals B and you multiply C both sides, as long as C is not equal to 0, those are still equal. Properties of equality. All right, if you multiply by 0, you get zeros. So that's why there's the exception there. You can't multiply by 0. Also, division property of equality. If A equals B and you divide both sides by C, those are still equal unless C equals 0. If you remember, you cannot divide by 0 or it's undefined. So that's the stipulation there. So make sure you know your vocabulary and your properties. Now, let's put those to use. All right, so it says solve equations using addition, subtraction, multiplication, and division. All right, so number 1 says x minus 3 equals negative 5. So let's add 3 to both sides. Negative 5 plus 3 is negative 2. And then number 2 says 0.9 equals y plus 2.8. So y is my variable. So this time we're trying to get the y by itself. So we're working on the other side of the equation. So we're going to subtract 2.8 from both sides. So we're going to have y by itself equals, and you're going to do 0.9 minus 2.8 is negative 1.9. All right, and you can always plug these in to check them. Negative 1.9 plus 2.8 is 0.9. Negative 2 minus 3 is negative 5. So those check very easily. N plus 3 equals negative 7, so I'm going to subtract, use my subtraction property, subtract 3 from both sides. Negative 7 minus 3 is negative 10. That's supposed to be in there. All right, g minus 1/3, so I'm going to add 1/3. You see that we're doing the opposite or the inverse operation for each of these. So g, the negative and positive are the same thing, cancel, leaves g by itself. Negative 2/3 plus 1/3 is negative 1/3. You can plug it in to check it. Negative 1/3 minus 1/3 is negative 2/3. All right, number 5, we've got negative n divided by 5 equals negative 3. So we have division. The inverse of that is multiplication. I need a positive n, so a negative times a negative is a positive. So I'm going to multiply both sides by negative 5. It's really negative 5 over 1, so this cancels. Negative 1 and negative 1 become positive, and that leaves just n. Now, whatever you do to one side, have to do the same thing to the other side. That's your properties of equality. So n equals negative 3 times negative 5 is positive 15. So check it. is negative 15 divided by 5 equal to negative 3? Yes, it is. All right, so this one has pi, which is just a number. Remember, it's approximately equal to 3.14. It's an irrational number, but a lot of times we just use it as 3.14, but we're solving for x, not pi. And so pi times x equals negative 2 pi. So we're going to divide both sides by pi because we have multiplication. The inverse of multiplication is division. X equals negative 2 pi divided by pi is negative 2. All right, so here, number 5, we had division, so we multiplied both sides. Number 6, we have multiplication, so we divide both sides. Number 1, we had negative 3, so we added 3. And here we had plus 2, so we subtracted 2.8. So if you look back at the examples that we've done, you'll see that you're doing the inverse operation to get the variable by itself. So number 7, take a second, do it by itself. You've got 1.3 times z equals 5.2. So take a minute and see if you can solve that. All right, so hopefully you did division since we're doing the inverse of multiplication. And z equals 5.2 divided by 1.3 is 4. All right, number 8, we've got multiplication. Go ahead and try it as well. Okay, hopefully you divided. Again, we have multiplication. The inverse of that is division. So we're going to do W equals 1.4 divided by 0.05. Whatever's on this side, remember you have to divide by the same thing, so you get the variable by itself. 1.4 divided by 0.05 equals 28. And again, you can check that. What is 28 times 0.05? 28 times 0.05 is 1.4. So when you plug it in, it does check, and so that is correct. All right, some key ideas that you need to remember here. So problem-solving plan, you need to understand the problem. What is the unknown? What information is given and what's being asked? Then you need to make a plan, decide how you will solve it. Your plan might involve one or more problem-solving strategies. Check and solve, carry out your plan, examine your solution, then check that your solution makes sense in the original problem. All right, so here's some common problem-solving strategies that you can use. All right, so let's see what we've got. All right, so modeling a real-life example. In 2016 Olympics, Usain Bolt won the 200-meter dash with a time of 19.78 seconds. Find his average speed to the nearest hundredth of a meter per second. All right, so let's look at what we have. So don't forget, it says remember the formula that relates distance, rate, and time is D equals R times T. All right, so we are given 200 meters as a distance, and we're given a time. So if we have D equals rate times time, we can replace the distance with 200. We don't know the rate, but we do know the time, 19.78 seconds. All right, so we've got multiplication. Remember that the opposite of multiplication is division. So to find R, we're going to divide both sides by 19.78. So 200 divided by 19.78, your rate equals 10.11. All right, so Bolt's average speed was about 10.11 meters per second. All right. That's blazing fast. All right. All right, so go back to the question and make sure we answered it. It says find his average speed to the nearest hundredth of a meter per second. All right, the hundredth of a meter is 2 decimal places, so we did that. Meters per second. So both average speed was about 10.11 meters per second. And to find out if this is accurate or this makes sense, all we'd have to do is take 10.11 and replace it for R. So take 10.11 meters per second and multiply that by the 19.78. And when you do that, you get 199.9758, which is very close to 200 meters as your distance. So because these numbers are rounded, that's why it's not exactly 200, but that shows you that that is a good answer for that problem. All right, the next question says, on January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to -4 degrees at 9:27 a.m. Shoo, in 27 minutes. That's a big drop. All right, so how many degrees did the temperature fall? So that's what they want to know. How many degrees did the temperature fall? So the first thing we need to do is talk about those strategies. So how are we going to solve this? So first you need to understand the problem. So you know the temperature before and after the temperature fell. And you are asked to find how many degrees the temperature actually did fall. So the first thing we can do is kind of make a plan. Think about it as a verbal model. So you can write an equation that represents the problem. So if we think about this verbally, so we know how many degrees it is at 9 a.m. and we knew how many degrees it is at 9:27. So we can write a model that says 54 degrees at 9 to -4 at 9:27. So we know it ended up at -4. So let's start with the temperature. Temperature at 9:27. And that's going to equal the temperature it started at, which is 9 a.m., and then minus the number of degrees the temperature fell. If you can read this. All right, so the temperature at 9:27, that's our final answer. We know that at 9:27 it was -4 degrees. So let's plug these in. And then at 9 a.m., so it says it fell from 54, so it was at 54 degrees at 9 a.m., and it fell to -4. So we need to know how many degrees it fell. We don't know that, so let's put T, and then we'll solve for T. All right, so what we can do is, since this is plus 54, we can subtract 54 from both sides. So we've got -4 minus 54, which is -58. And that equals minus T. Now remember, we want the temperature, not negative T, but just T. So divide by -1. Anything divided by -1 is just going to change the sign. So -58 divided by -1 is just 58 equals T. So how many degrees did the temperature fall? The temperature fell 58 degrees in a mere 27 minutes. That's incredible. All right, don't forget to check it. Plug it back in. 54 minus 58. What's 54 minus 58? It is -4. So if you plug that in, that does work. All right, I hope this helps. Have a good day.